Hello. Well, today I was testing my little C application. Um, what it does is that it parses the Quick 1 and Quick 2 pack files, and it shows you, the items in the pack file. And I noticed that with one particular file, it gets a bit slow, like you see a hiccup for a second or a second and a half or something like that, or maybe even less than a second, but you can, notice that. And I was wondering why this happens. I had an idea already, but I just wanted to make sure that that's the case. And it gave me the excuse to start using Tracy. I always liked Tracy. I never used it before, but I thought it's a cool tool, and now it was the best opportunity for me to start using it. So now I have built my code and linked it with the Tracy. So now when my code runs, which is it running here, it is able to actually connect to Tracy. I think this instance is dead maybe. So I'm just making the code one more time. And now, yes, Tracy is able to see my binary. So now here is the big file, which is 1.6 gigabyte, and my code is being profiled, and it is built with debug information, so it's a bit slower in this situation. So now I'm dropping the file here, and it took, oh shit, I forgot to start the profiler, so I have to do it again. Uh, so let me run the code one more time. Now I'll start the profiler, so I connect it to my app, and it's collecting information, and now it's done. We stop, and well, it has clearly showed me where the code actually, if I can, yes. Uh, so now in the like the Tracy view, on the main thread, we can see the whole lifetime of the app. I ran it for a bit over 5 seconds, and this is where I dropped the file, and you can see the slowdown here clearly. You can easily see this, uh, and I put, I instrumented the code manually uh, everywhere. I put instrumentation everywhere. Unfortunately, the C version of Tracy, or the C binding of Tracy, because it is written in C++, does not automatically, do the do a lot of things. So you have to manually, place this Tracy zone function, and then you have to manually close it. At least I guess in C++ you don't have to do this part, but that's fine. So now you can see that the app calls the app pack input, and then handle file drop, and then it calls IO load file, and then eventually inside the IO load file, I just added this extra thingy here for fread. You can see this IO load file fread. It spends almost the whole time, uh, you know, um, reading the file from disk. While this is a pretty old laptop, and I particularly specifically decided to use this laptop to develop this app. I have a Mac M4 Mini. I can use that, but I decided to use this old laptop because I was like, I am like, if this application runs fast and snappy on this crappy machine, then it will run fast everywhere. So now I know, I already had an idea, as I mentioned, that this is the bottleneck. So I should not read the whole file in one go, or I have to split yeah, I have to split the file. But due to the nature of the code, I don't even need to read the whole file. I just need to open the file and jump around and just read those section of the file that I actually need. I have to give it a go, but I guess that is a much that is going to be a much faster solution. So I just move the file pointer or seeker, and I just read the parts of the code that I want, and then I can discard the uh, uh, file descriptor. So yeah, that's just basically what I wanted to talk about. I was excited about this, and I have to tell this tool is absolutely amazing. Uh, Here on the top is a frame, uh, it shows the frames, but I have disabled it, or I did not instrument my code to capture the frame. But you can technically, if you're writing a graphical application, then you can capture the frame, so it shows you the frames, how long each frame took. Uh, and this view is the function call view, where you can see how long each function actually took to execute. Well, cool. Okay, thanks for watching.